Example 3 for elimination. As I look at these two equations, I'm being forced to use this method of elimination. When I first look at this would be a great problem for substitution because I could take the y and substitute its rule in right down here and solve. But because it says to use elimination, I'm going to want to put these equations in standard form. For the first equation, it's in slope-intercept form. I need to get the x into the first position and get rid of any fractions. So what I'm going to do is multiply by 3 as my very first step. And so when I multiply by 3, equation 1 times 3, I would get 3y equaling x plus 15. Again, all I did was multiply by 3. 3 times y was 3y. 3 times a third was 1, so it's 1x. 3 times 5 is 15. Now I'll move that x to the first position. As I move the x to the first position, I get negative x. Remember, it becomes a negative as we move it across the equal sign. Plus 3y equal 15. As we've learned from our book, this isn't technically standard form because standard form requires that first term to be positive. But for the elimination method, it's okay to leave it negative. And so I can stop there. Now that was equation 1. It is important to know which equations you're working with. So I'm going to bring that second equation down and start the problem anew. I'll call this equation 2. 2x plus y equal 19. From here, I have to decide, I'm looking right here, whether I want to get rid of my x's or my y's. You can't choose wrong. You just have to make a choice. In this case, I think I'm going to get rid of my x's since they're already opposite in value. All I'd have to do is multiply equation 1 by 2. And so I can distribute a 2 across this. That would make this negative 2x plus 6y equaling 30. For the second equation, it'll already be equal but opposite in value, so I can just rewrite it as 2x plus y equaling 19. Once I've achieved equal but opposite coefficients, I can simply add the two equations up. As I said in the last example, sometimes they call elimination a linear combination because of this step. You combine the two equations. The x's drop out, 6y and 1y is 7y, equaling 49. Well, if 7y equals 49, I can simply divide both sides by 7. And I get a y value. Y equals 7. Pardon me. Y equals 7. Now I come up here. That's my y value. To find an x value, I can simply plug that in. I think I'll go to the second equation here. You can go plug it into any equation you want, but I tend to go for one of the easier ones. And so I'll say 2x plus 7 is equal to 19. All I did was put the 7 in for the y. Now as I solve this, I can move the 7 over. 2x is equal to 19 minus 7. 19 minus 7, of course, is 12. Divide by 2, divide by 2, x is 6. And there I found a point of intersection. That's linear combination, also known as elimination. Example number 3.